Hi guys, Dr. Nizam here. This is full online courses or FOC for Engineering Mechanics Static class, lecture number 6. We are going to continue from the previous class on the topic of Force 3D. Force 3D, we're gonna go on this part, which is dot product. This is the last part for the Force 3D. Okay, before this, we learn on the problem that involve only one vector Cartesian, whether it is for force or distance, the one that we call it as position vector, still remember? So now, what if there is more than one vector Cartesian system of force? How we want to determine the angle between those vector force and how to determine the projection of a vector along the specified line. So here where the dot product is come in. Alright. So this time we are going to learn about the dot product, and this is the list of the topic, which is application, dot product, definitions, angle determination, and determining the projection. Alright, now let's look at this picture. Do you still remember about position vector? Before this, we only have a Cartesian vector for this system. For this system, this is pole on this system, and the Cartesian vector is for this vector position, or we can denote it as R. This is R. Still remember? And in this case, we denote it as ROA. Okay. If there is a force, then the force is act at the same direction of the pole. Okay. So what if the force act at different direction of the pole, like this force, this F1, F2 force. Okay. And not only the pole have the Cartesian vector, the force itself have a Cartesian vector. Okay. So here the function of dot product is needed. Okay. The dot product can be used to multiply the Cartesian vector of the pole and the Cartesian vector of the force, which then it can be used to determine the angle of these two vectors, and then this one also. Okay. Okay, now let's consider the pole is the vector position, and the force F2 is another Cartesian vector. Pole is one Cartesian vector. Force is one Cartesian vector. Okay, let's say A is pole, B is the force. You just look in the previous slide. A have its Cartesian vector, and B is also have its own Cartesian vector. So between those vectors, there's the angle here, angle theta. So the dot product you can use to multiply between vector A and vector B. So it is like this. The dot product of vectors A and B is defined as A dot B, which is equal to AB. A is a magnitude for vector A, and B is the magnitude for vector B, cos theta. Normally between force F and the distance R. So just like I said, let's say F is a force, A is a distance R. Okay. Like this. This is our R, the pole is R, distance, and the force is the cable. Angle theta is the smallest angle between the two vectors and is always in a range of 0 degree to 880 degree. Okay, here is the characteristic of dot products. First, the result of dot product is a scalar, which is only magnitude. Okay, the unit of the dot product will be the product of the units of the A and B vectors, vector, any magnitude and direction. Okay, let's look at this example. I is at x-axis and j is y-axis, so it's in the condition of perpendicular to each other. So it is cos 90 degree. Cos 90 is equal to 0. Whereas I dot I is a parallel between x and x-axis, it is parallel, so the cosine is 0 degree. 0 degree is equal, cos 0 degree is equal to 1. Okay, if you do the A dot B dot product, the product is AI plus AJ plus AK dot BI plus BJ plus BK. So you need to do the multiplication AX BX II and then AX BY IJ AX BZ IK, okay, and then move to AYJ multiply with BXI, AYJ multiply with BYJ, AYJ multiply with BZK, and so on. So the IJ, anything that multiply I and J, it should equal to 0, and then II equal to 1, or JJ or KK, and so on. So in the end, you will get this formula after you eliminate the IJ, which is equal to 0, and then II you multiply with 1. So the end product of the dot product A dot B should be equal like this, AX BX plus AY BY plus AZ BZ. Okay, so here, thus to determine the dot product of two Cartesian vector, okay, two Cartesian vector, you have the pole one Cartesian and then the force one Cartesian, another one Cartesian vectors. Multiply their correspondingly S, Y, Z component and sum their product algebraically. Okay, now if you want to find angle between two vectors in Cartesian form, there's two vectors, each have their Cartesian form. So if you want to find the angle here, so you need to do the dot product. Okay, so finding the dot product, A dot B is equal to AX BX plus AY BY plus BZ AZ BZ, and then finding the magnitudes for A and B of the vectors A and B, and using the definition of dot product, and solving for theta. So we will see to find the theta, so you need to do this formula, A dot B per AB. This is a unit vector. If you still remember, unit vector is equal to cos theta. So to get the theta, you just inverse the cos. Okay, using dot product, you can also determine the component of vector which is parallel and perpendicular to a line. Okay. So how we do it? So for step 1, find the unit vector UAA prime along line AA prime. So you need to find the unit vector from A to A prime. Okay, and then find the scalar projection of A along line AA prime, okay, by using this formula. This one is these two lines here, to denote this is a parallel. Okay, A parallel equal to A dot U. A dot U is a unit vector. This is equal to AX UX plus AY UY plus AZ UZ. Okay, and then if you want to find the projection, you can write this A parallel in the vector form. So you need to use this formula. A vector is equal to magnitude of A multiplied with unit vector AA prime. The scalar and vector form of the perpendicular component can easily be obtained by, okay, that one you get the A parallel. So if you want to get the perpendicular one, so the equation, the formula is like this. A perpendicular equal to A minus A parallel. Okay. Okay, now let's do some example. The force given the force acting on the pole. Okay, so you have a pole here. Okay, remember the pole is R radius. Okay, and then they have a force here acting in the different direction of the pole, and it has their vector Cartesian system here, which is F equal to I plus 4j plus 10k. The force is not in the scalar magnitude form, but it instead of it's given in the form of Cartesian vector. Okay, you need to find the angle between the force vector and the pole. The force vector and the pole, you need to find the angle here, and the magnitude of the projection of the force along the pole OA. Okay, so you need to find the force along the OA, which we call it as projection. Okay, so here the plans. So first you need to get the ROA, which is the radius here, ROA, and then you get the angle theta equal to cosine inverse F. Dot product with ROA, you just find it in the first step, and then divide with F magnitude ROA. Still remember the unit vector. So what's the formula? The unit vector is vector form divide with magnitude, okay, or scalar. And then number 3, you need to find the projection of force along the pole, which is FOA. FOA. So FOA is equal to F. You dot product with the unit vector of OA, or you can also use F cos theta. Okay, now let's find ROA first. So ROA is a distance from O to A, distance for R. Still remember the vector position. Vector position is the same thing for R with the ROA, which is you need to find the coordinate of A and O. So in this case, A is in the origin, and then O, the coordinate is 2 to 1. Okay, 2 in the x direction. In the x direction, and then 2 is y direction, then 1 is z. So if you still remember the formula for position vector, which is xb minus xa, still remember the tip minus with tail. So this one is 2 minus 0, 2 minus 0, and then 1 minus 0. So the Cartesian vector for ROA is 2i plus 2j minus 1k meter. Okay, if you want to get the magnitude of this vector Cartesian, you need to square and then square root. So you will get the distance between O to A is 3 meter. Okay, like I said, you have two Cartesian vector system, which is ROA Cartesian vector, and then another one Cartesian vector, which is force Cartesian vector, which given in this question. So your Cartesian vector for F is 2i plus 4j plus 10k. Okay, this is your Cartesian vector for force, and then this is your Cartesian vector for distance. So the Cartesian from the Cartesian vector of F, you can get the magnitude and the scalar also, which you can square and then square root, and then you will get the scalar magnitude for F is equal to 10.95 kilonewton. Okay, next is to do the dot product between these two Cartesian vector. Okay, so these two Cartesian vector you can multiply it, and then which is f dot ROA. So simply you can multiply directly I with I, j with j, and k with k. Remember, if you still remember, the formula of dot product is like this. Okay, a dot b is ax bx, ay by, and az bz. Okay, let's go to the slide again. Okay, so the same thing. So if you want to do the multiplication of the dot product, so you do like this lah. 2 with 2, 2 with 4, j, and then 1 with negative 1 with 10. Okay, so you will get the scalar magnitude of f dot ROA is 2 kilonewton per 2 kilonewton meter. Okay, from here, if you still remember, the formula of this cos theta is equal to vector dot product of vector divide with the scalar magnitudes, or cos theta equal to unit vector. Okay, unit vector is equal to vector divide with scalar magnitude. Okay, so using this formula, cos theta equal to the dot product of vector for unit vector is actually the vector divide with scalar magnitude, but in this case, vector is the dot product of these two vector. Okay, vector Cartesian. So divide with the what you call it, the scalar magnitude. Okay, so the vector here is to divide with the scalar magnitude of f and ROA, force and the distance, which is the force is 1095 kilonewton and the distance is 3 meter. So you multiply it. Okay, and then you inverse the cosine, so you will get the theta. Okay, so the theta here is 86.5. Okay, now the question asks you to find the projection force of FOA. So how you want to find it? So FOA is actually equal to the dot product of Cartesian vector of F, this F, the Cartesian vector, and then dot product with unit vector of UOA. Just now you get the UOA. So the dot product is still multiply the Cartesian vector of F and then Cartesian vector of UOA. So Cartesian vector of F is 2, 4, 10, and then you multiply with Cartesian vector of unit vector UOA. So unit vector you just circle it now is 2 per 3, and then you divide with the Cartesian vector of F. So you will get the projection force of FOA is equal to 0.667 kilonewton. Or you can also use this formula, FOA is also equal to F cos theta. Look back at this formula. Okay, the dot product of A dot B is also equal to AB cos theta. So this dot product F dot UOA is also equal to F cos theta. So F is is a scalar magnitude for this force, which is 10.95 kilonewton. Okay, and then cos theta is, we just calculate from this formula. Cos theta is equal to dot product of Cartesian vector for FROA and the scalar magnitude for FROA. Okay, which is the theta is equal to 86.5. So just substitute into this equation, so we'll get the same answer with this one. Yeah? Okay, so any formula you can use as long as you get the answer. Okay, now let's do another example. So if you have a pipe like this, okay, so and then force acting in this direction. Okay, so this time it is given that the pipe is a distance, and then the force, so you have distance and force. Okay, there are two vectors basically. Okay, so the first vector should have its own Cartesian vector, and then the force here also should have its own Cartesian system. But this time the F is not in the Cartesian form, it's given in a magnitude form, which is 100 Newton. So it is needed to change this form, this magnitude form, into Cartesian vector forms. So then you can do the dot product to get the projected component of force C to B. So here the step, you need to get the RCD and RCB. Here this is the RCB, and you need to also create the radius here, the vector position for this force, and then from the radius or the vector position, get the unit vector for those CD and CB. Okay, using that unit vector you can get the FCB. Okay. Okay guys, the question asks you to get the projected force of FCD. So the projected force of FCD is FCB. Okay, simply using this formula, if you know the theta here, okay, so using the cosine rule, here is FCB and then here is FCD. The cosine rules means that FCB per FCD, don't look this first. Okay, FCB and F per FCD equals to cos theta. Okay, so you need to get the theta. Okay, first of all, you need to find the FCB and then find the FCD. Okay, so to find the FCD, so if you want to find the FCB, so you need to move the FCD to the other side, which means FCB is equal to FCD cos theta. So FCD is 100 Newton, it is given. So your task is to find the theta. So formula for theta, before this we learn, it is cos theta is equal to this is unit vector. Okay, the up here is a vector, down here is a magnitude. So the vector is for FCD, vector FCD for in a Cartesian form, RCB in a Cartesian form. So if you remember Cartesian form, if you want to multiply with Cartesian form, we use the dot product. Okay, and then down here is a magnitude for FCD and magnitude for RCB. So you need to find RCB in Cartesian form, and then FCD Cartesian form, number 1, number 2, and then number 3 F or RCB in scalar magnitude form. This is Cartesian vector form, Cartesian vector form. So these two is vector, and then number 4 is FCD scalar magnitude form. So these two is magnitude. Okay, so first we're going to get the RCB in Cartesian form. So how we do it? Still remember the vector position. So vector position is RCB equal to x minus xb minus xci plus yb minus ycj plus zb minus zck. Okay, so this will give you a Cartesian form vector for RCB. So first, what is xb, yb and zb, and what is xc, yc and zc? Okay, so you need to find the coordinate first, the coordinate for B and coordinate for C. So the coordinate for B I already write down here. So coordinate for B for x, y, z. B is here, in the picture is here, it is in the origin, so the coordinate is 0, 0, 0. Okay, and then coordinate for C, x, y, z. So x is in this direction, which is 0.6, and then y, coordinate for y is 0.4, and then coordinate for z is down here, 0.2. so because it is downward, so the direction is negative. And then you also will need to define the coordinate for D. So the coordinate for D is in x direction is 0, because they not move on the x direction. So for y coordinate is 1.2, and then for z also 0. Sorry, the z is 0. Okay, so if you want to get the RCB, vector position of CB or radius, you can write here R, vector position for this one, CB, R. So you can write like this, R CB is equal to XB minus XC I plus YB minus YC J plus ZB minus ZC K. So just substitute using those coordinate here. So what is XB? XB is 0 minus XC 0.6 I plus 0 minus 0.4 J plus 0 minus -2. Okay, so this you will get the Cartesian vector for RCB is -0.6 I minus 0.4 J plus 0.2 K meter. Okay, this is a vector. So for magnitude for RCB, as usual, RCB, so you need to square and square root 0.6 squared 0.8 squared plus 0.2 squared. So you will get 1.02 meter. Okay, so you already get the Cartesian vector form for RCB, which is this one. Okay, this one, and then the magnitude scalar form for RCB, which is this one. Okay, next is to determine the Cartesian vector form for FCD. The one is given is in the magnitude form. Okay, and then to change the scalar magnitude of f equal to 100 into the Cartesian vector forms, you can use this formula. Magnitude you multiply with the unit vector UCD. FCD you multiply with the UCD. So unit vector UCD, it is equal to the, you can use the vector position for CD, vector position for this CD, C2D, which is RCD. So unit vector is equal to RCD in a vector Cartesian form, and then divide by RCD in a magnitude form. So to get the RCD in a vector Cartesian form, so you need to do the same thing as you want to find the RCB. Okay, so RCD is equal to XCD minus XC plus YD minus YC plus ZD minus ZC. Okay, coordinate for D and C you already know, so you already defined here. Okay, so just substitute and you will get the Cartesian vector form for RCD is equal to negative 0.6i plus 0.8j plus 0.2k. Okay, so this is your Cartesian vector form for RCD. So for magnitude, RCD is equal to 0.6 squared plus 0.8 squared plus 0.2 squared. This is equal to 0.75 meter. Okay, so UCD is 0.575 meter. Okay, so UCD is equal to the vector form, the vector in Cartesian form, which is 0.6i plus 0.8j plus 0.2k divided by the magnitude 0.75. This is equal to, the UCD is a what is it, 0.588i plus 0.784j plus 0.17196k. Okay, sorry, this is not 0.75, this is 1.02. okay, so this one is 1.02. okay, so after you get the unit vector, you can multiply with the scalar magnitude of FCD, which is 100. So you will get FCD in the Cartesian vector form. So FCD in a Cartesian vector form is equal to 100 multiply with 0.588, okay, I plus 100 0.78j, sorry, then plus 100 0.196 K. Okay, so you will get the FCD in Cartesian vector form, negative 58.8 I plus 78.4 J plus 19.6 K Newton. Okay, so now you have the FCD in Cartesian form. So let's look at the formula here. So your aim is to get the theta, right? So using this formula, FCD in Cartesian form, dot product with RCB in a Cartesian form, dot product because you want to multiply two Cartesian form, which is FCD and RCB, divide by FCD in magnitude form, multiply with RCB in magnitude form. Let's write it right. Theta FCD dot product with RCB FCD RCB. So just substitute your FCD here and RCB. Where is your RCB? This is your RCB. So just substitute. Okay, so FCD dot product with RCB, you will simply multiply x with x, y with y, and z with z. Remember the dot product formula: 58.8 negative 0.6, 78.4 to 0.4 plus 19.6 0.2 equal to 7.84 Newton meter. Okay, so from here substitute into this equation. So cos theta equal to 7.84 divided by FCD in a scalar magnitude. What is the value? 100. Multiply with RCB in a magnitude value. What is the value? RCB is 0.75. Sorry, 0.75 meter. Okay. So multiply with 0.75 meter. So theta, you cosine inverse so you will get the theta is 84 degree. Okay, so you get the theta. So using this formula here, we just derived back then, so you will get the FCB. The FCB is equal to FCD cos theta. Your FCD is 100, cos theta 84 degree, so it is equal to 10.5 Newton. So this is your force FCB, or projected force. FCB here is force here, FCB. Okay, that's all.